Okay, welcome back to our flipped classroom. And today I'm going over the stoichiometry practice problems. And so this is just to help you work through the problems. And so I'll be talking through them as I solve them. So in this particular practice worksheet, we have 4 equations at the top, and then it tells us to use the balanced equations from the problems above to answer the questions at the bottom. So the first thing we have to do is balance our equations. So let's go ahead and zoom in just a little bit so you guys can see those a little better. Oh, evidently we can't do that. So here are our equations. We have C6H10, so we have hexane, and then we have, or hexene actually, we have oxygen, we have carbon dioxide and water. So we recognize this as a combustion problem. So we're going to look at this and we're going to see that initially our first thought is, okay, I have 6 carbons. So I'm going to put a 6 here for carbons, and that takes care of the carbons. And then I have 10 oxygen or hydrogens. So I'm going to put a 5 in front of water. So that gives me my 10 hydrogens. But the problem with that is that I now have 12 oxygens plus 5 oxygens gives me 17 oxygens, and there's nothing I can multiply this 2 by to get 17, except if I thought about it, I could multiply this by 17 over 2, and that would give me 17 oxygens. But we can't leave this fraction here. And so the way we're going to solve that problem is that instead of 17 over 2, we're going to put a 17 here. So we have 17 oxygens. And then instead of a 6, that means that I need twice as many. So I'm going to put 12 in front of the carbon dioxide. And I still need twice as many waters. So instead of a 5, I'm going to put a 10. So now if we check the oxygen, I have 34 oxygen. And here I have 24 oxygen plus 10 oxygen gives me 34 oxygen. So we've solved we've solved the oxygen problem, but now I have 12 carbons and 20 hydrogens. And so I'm going to put a 2 in front of the C6H10, and that'll give me 12 carbons and 20 hydrogens. So we've balanced our chemical equation. So let's take a look at number 2. I can see that I have 1 hydrogen here and 1 hydrogen here. That gives me 2, and I have 2 on the product side. So far I'm doing okay. I have 1 bromine on the reactant side and 1 bromine on the product side. I have 1 potassium on the reactant side and 1 potassium on the product side. And I have 1 carbon and 1 carbon and 3 oxygens. And then on the other side, I have 1 here in water and 2 here in carbon dioxide. So I have 3. So all of these are just going to have a coefficient of 1. So we can write those in, or we can just leave them blank because we know that that means that there is a coefficient of 1. So we're going to jump down to the next one where we have gallium-3 bromide and we have sodium sulfite reacting to form gallium-3 sulfite and sodium bromide. So the first thing I notice is that I have 2 galliums on the right side and only 1 on the left. So I'm going to go ahead and put a 2 in front of gallium-3 bromide. And then I also notice that I have 3 sulfites on the right and only 1 on the left. So I'm going to go ahead and put a 3 here as well. So now I have 3 sulfites and 3 sulfites, 2 galliums and 2 galliums, but I have 6 bromine and only 1 on this side. So I'm going to go ahead and put a 6 in front of the sodium bromide, and that'll give me 6 sodiums as well, which matches up with what I have on my reactant side. So that one's already balanced. And then the last one, I've already balanced for you. So now that we have balanced equations, we remember that we always have 5 steps of stoichiometry. We're going to balance our equations, and then we're going to identify the given and the unknown. So for step 2, I need to identify the given and the unknown in my first problem. So in my first problem, as I read through, it tells me if I have 35 grams of C6H10 that react with an excess of oxygen, and it asks me how many grams of carbon dioxide will be formed. So what am I given? Well, I'm given 35 grams of C6H10. And what am I being asked to find? Grams of carbon dioxide. So we've done step 2. So step 3 is to convert the given into moles. And so I am going to start with what I'm given, which is 35 grams of C6H10. And now I know I want to convert this into moles. And since I already have grams, I know I'm going to use molar mass to do that conversion. So I need to calculate the molar mass. So it's going to be 6 times the mass of carbon, which is 12.01, plus 10 times the mass of hydrogen, which is 1.01. And we're going to have a mass of 82.17 grams of C6H10 in 1 mole of C6H10. So each time we're going to start with what we know, and we're going to determine what conversion factor do we need to get from this unit, given unit, to moles. And if we have mass, we know we need to use molar mass. So that's step 3. Now step 4 is always going to be to convert the moles of given to moles of unknown. And we're going to use the molar ratio to do that. And the molar ratio comes from our balanced chemical equation. So I'm going to go back to my balanced chemical equation. In my balanced chemical equation, I have 2 moles of C6H10, and I'm being asked to find carbon dioxide. So I have 12 moles of carbon dioxide. So I know I want to get rid of moles of C6H10. So I'm going to put the 2 moles of C6H10 at the bottom, and I'm going to put 12 moles of CO2 on the top. So I'm just going to stop and check to make sure that I'm doing everything in the right order here. So I have grams of C6H10 here, and I have grams of C6H10 on the bottom here. So those are going to cancel out. And now I have moles of C6H10 here and moles of C6H10 on the bottom. So those are going to cancel out. So now my final step is going to be to convert moles to whatever unit the problem asks for. So in this case, the question asks me to find grams. So I'm going to convert from moles of carbon dioxide to grams of carbon dioxide. And again, I'm going to have to calculate molar mass. So carbon, I have 1 carbon at 12.01 grams. And again, I'm going to the periodic table to find these. And then I have 2 oxygens at 16.00 grams. And so when I add that up, I get that there are 44.01 grams of carbon dioxide in every 1 mole of carbon dioxide. And again, I've put mole on the bottom here because I have it on the top here and I want them to be able to cancel out. So I know that they do cancel out, and I'm going to be left with the units that I was being asked to find, which are grams of carbon dioxide. So what I'm going to put into my calculator is 35 times 12 times 44.01 divided by, and now this needs to go in parentheses, 82.17 times 2. And when I do that, the answer that my calculator gives me is 112 point something. But I only had 2 significant figures. So I have to round that 112 so that it only has 2 significant figures. So there's 1 and there's another 1. And now there should be a 2 here, but that's not a significant figure. So I'm going to change it into a trailing 0. And that becomes 110. So 112 is about 110 grams of CO2. And so that's our answer. We're going to repeat that same process for all of our problems. So we're going to move down to our next problem. We're going to balance our chemical equation. Well, we've already done that. we want to identify the given and the unknown. So here's what we're going to do. We're going to identify our given by underlining it in pink, and we're going to identify our unknown by underlining it in blue. So in this question, I am given 13.4 grams of potassium hydrogen carbonate or potassium bicarbonate. And then it reacts with hydrobromic acid and asks me how many grams of water will be formed. So I'm looking for grams of water, so that's my unknown. So again, I'm going to start with what I know, which is 13.4 grams of potassium hydrogen carbonate. And I know I need to convert that into moles. And because I have grams, I know I need to look for molar mass. And so I'm going to turn to my periodic table, and I'm going to see that the mass of potassium is 39.10, and the mass of hydrogen is 1.01, and the mass of carbon is 12.01, that's a 1, and the mass of oxygen is 16.00, but I have 3 of them, so times 3. And when we add all of that up, we get 100.11 grams of potassium hydrogen carbonate in 1 mole of potassium hydrogen carbonate. And so I'm going to double check. I have grams on the top, grams of potassium hydrogen carbonate on the top, grams of potassium hydrogen carbonate on the bottom. Those cancel out. Now I'm going to change the moles of given to moles of unknown using the mole ratio from my balanced chemical equation. So on the bottom, I'm starting with moles of potassium hydrogen carbonate. So I'm going to put 1 mole of potassium hydrogen carbonate on the bottom. And I'm trying to convert that to the unknown, which is water. So I have 1 mole of water on the top. And then I'm asked to find grams. So I'm going to convert moles to grams because that's the unit I'm being asked to find. So again, I'm looking for molar mass. So the mass of hydrogen is 1.01, and there are 2 of them. And the mass of oxygen is 16.00. And so we're going to add that up, and we get 18.02 grams of water in every 1 mole of water. And now I'm just going to double check that I have all of my conversion factors in the right places. So I have mole of potassium hydrogen carbonate on the top, mole of potassium hydrogen carbonate on the bottom. So that cancels out. Mole of water on the top, mole of water on the bottom. So that cancels out. And now I have 13.4 times 18.02 divided by 100.11. And that's going to give me 3 significant figures, 2.41 grams of water. Okay, so hopefully this is starting to come clear as we go through this process. So we're going to repeat this with our next problem. Again, we're going to identify our given by underlining it in pink and our unknown by underlining it in blue. So our given, in this case, we're given 5.22 grams of solid gallium-3 sulfite. So it's important that we pay attention as we're doing these to what the mass is, what substance the mass is, and recognize that here we're being given gallium-3 sulfite. That's a product. It doesn't matter whether we start with products or reactants, we just need to know what we're starting with. And it asks us to find how many grams of sodium sulfite were consumed. So grams of sodium sulfite are my unknown. So I'm starting with a product and trying to figure out how much reactant I must have used. So we're starting with what we know. 5.22 grams of gallium-3 sulfite, which is Ga2SO3. And I'm going to convert that into moles because I'm starting in grams, I'm going to use molar mass. Again, I'm going to do 2 times the mass of gallium, 3 times the mass of sulfur, but now the oxygen is 3 times 3, so it's going to be 9. So mass of gallium, let's double check here, mass of gallium is 69.72, 69.72 times 2 plus sulfur times 3, so that's 32.67 times 3 plus oxygen, which is 16.00 times 9. And so again, when we add all of those up, there we go, we get 379.65 grams of gallium-3 sulfite in 1 mole of gallium-3 sulfite. And now I'm going to convert the moles of given to moles of unknown. So right now I have moles of gallium-3 sulfite. So I'm going to look at my balanced chemical equation. I can see that there's 1 mole of gallium-3 sulfite in that equation. And on the top, I'm trying to find grams of sodium sulfite. So I'm going to look at my balanced chemical equation and I'm going to see that I have 3 moles of sodium sulfite. So 3 moles of Na2SO3. And then my last step is going to be converting moles to the unit that I'm asked to find. Again, I'm being asked to find grams, so I'm going to go to molar masses. So 1 mole of sodium sulfite here on the bottom. And we're going to have 22.99 plus, times 2, because I have 2 sodiums, plus 32.67 plus 16.00 times 3. And when we add all of that up, we get 126.04 grams of sodium sulfite. And so I'm going to have 5.22 times 3 times 126.04 divided by 379.65. And I'm just going to double check. So I have grams of gallium-3 sulfite and grams of gallium-3 sulfite. So those cancel out. Moles of gallium-3 sulfite and moles of gallium-3 sulfite, and those cancel out. Moles of sodium sulfite and moles of sodium sulfite, and those all cancel out. And when I plug all of that into my calculator, recognize that I should have 3 significant figures when I'm done. I get 5.20 grams of sodium sulfite. And last one. Again, we're going to balance our chemical equation. It's already balanced for us. We're going to identify the given and the unknown. And my shortcut here today is that I'm identifying the given in pink and the unknown in blue. So I read my question. If 74.33 grams of tin 2 oxide, so there's my given, that's what I'm told, react with an excess of nitrogen trifluoride, how many grams of tin 2 fluoride are formed? So I am looking for grams of tin 2 fluoride. So as before, I'm going to start with what I know, 74.33 grams of tin 2 oxide. So that's SNO. I have grams. I want to convert the given into moles. So I'm going to have to find the molar mass. So molar mass of tin is 118.71. And the molar mass of oxygen is 16.00. And so that gives me a molar mass of 134.71 grams of tin 2 oxide. per 1 mole of tin 2 oxide. And now we're going to convert moles of given to moles of unknown. So in my balanced chemical equation, I have 3 moles of tin 2 oxide, and I have 3 moles of tin 2 fluoride. And then my last step is going to be to convert the moles to the unit that I'm asked to find. And so I'm going to put moles on the bottom, 1 mole of tin 2 fluoride. And on the top, I'm going to put the molar mass of tin 2 fluoride because I'm being asked to find grams. So again, 118.71, but now we have fluoride, which is 19.00, and there are 2 of those. And so that molar mass comes out to be 156.71 grams of tin 2 fluoride. And now we're going to double check that we have all of the units canceling out. So I have grams of tin 2 oxide on the top and grams of tin 2 oxide on the bottom. Next, I have moles of tin 2 oxide and moles of tin 2 oxide. And I have moles of tin 2 fluoride and moles of tin 2 fluoride. So we're going to cross those out, and I'm left with grams of tin 2 fluoride. So we have 74.33 times 3 divided by 156.71, or times 156.71, sorry, divided by 134.71 times 3. And remember, if you're putting all of this into your calculator at once, divide by parentheses 134.71 times 3 end parentheses. And when we put all of that into our calculator, we get 86. I have 4 significant figures, 0.47 grams of tin 2 fluoride. And that's how we solve those problems. So remember, the process is always the same. It doesn't matter whether we start with products or reactants, whether we're finding products or reactants, our first step is always going to be to balance our equation. If we don't have a balanced chemical equation, we can't do stoichiometry. The next step is to identify the given and the unknown, convert the given into moles if necessary, convert the moles of given to moles of unknown using your balanced chemical equation, using those coefficients, and then convert the moles of unknown to the unit that's asked. In every example we did today, we were starting with grams and ending with grams. But we know 2 other conversion factors for moles, so it would be possible that you would be asked to find volume of a gas or particles or atoms. As always, let me know if you have any questions. I look forward to seeing you in class.